Have you ever wondered if there was something out there dragging our universe along with it? Sounds like a sci-fi movie plot, right? Well, what if I told you that scientists actually believe this might be true? And it's not just any ordinary object that's dragging our universe. It's an anomaly in space known as the dark flow. In this video, we will delve into the depths of the dark flow and explore the mind-boggling implications of its existence. The discovery of the dark flow has left scientists scratching their heads and searching for answers. So sit back and prepare to be amazed by the incredible mysteries of our universe. Let's get started. The term flow might conjure up images of water flowing smoothly or a river meandering through a landscape. However, in the context of space, the dark flow refers to a phenomenon that is anything but smooth. The dark flow is a strange and mysterious force that is pulling galaxies in all directions away from each other. This discovery has shocked the scientific community and raised more questions than answers. What is causing this flow? Is it a sign of a larger, more complex structure in the universe? Or could it be something even more sinister? But before we dive into the murky depths of the dark flow, let's take a step back and explore the basics of how we measure movement in space. After all, how do we know that galaxies are moving away from each other in the first place? To understand this, we need to look at something called redshift. Redshift is a way of measuring how fast an object in space is moving away from us. The light from distant galaxies is stretched as they recede, causing them to appear redder than galaxies that are closer to us. By measuring the amount of redshift in a galaxy's light, scientists can calculate how fast it's moving away from us. In the early days of astronomy, scientists noticed that the light from distant galaxies was shifted towards the red end of the spectrum. This observation led to the groundbreaking realization that the universe is expanding. As space itself stretches, galaxies are carried along with it, moving away from each other. But as the universe expanded, scientists noticed something strange was happening. Some galaxies were moving away from each other faster than expected, while others seemed to be moving towards each other. This unexpected behavior couldn't be explained by the Big Bang theory alone, and scientists began to wonder if there was something more going on. Enter the dark flow. In 2008, a team of astronomers led by Daniel J. Lapostro at the University of Chicago made a shocking discovery. They found evidence of a vast anomaly in the universe that was dragging galaxies towards it with an astonishing speed of 63 miles per second. The strange thing was that this anomaly wasn't in one part of the universe or another. It seemed to be everywhere. They named it the dark flow. At first, scientists were skeptical. Could there really be something so massive that it was affecting the entire universe? But as more data came in, the picture became clearer. The dark flow was real. But what exactly is the dark flow? Scientists don't know for sure, but they have some theories. One idea is that the dark flow is caused by a large concentration of dark matter. Dark matter is a mysterious substance that makes up a significant portion of the universe, but we can't see it or interact with it directly. If there was a huge amount of dark matter in one part of the universe, it could create a gravitational pull that affects galaxies over vast distances. Another theory is that the dark flow is caused by a cosmic string. A cosmic string is a hypothetical one-dimensional defect in space-time that could have been created in the early moments of the Big Bang. These strings would be incredibly dense and massive, and their gravity could affect galaxies over billions of light years. While these theories are still just that, theories, they provide an intriguing glimpse into the potential causes of this mysterious phenomenon. But whatever the cause, the effects of the dark flow are undeniable. Galaxies are moving towards it with incredible speeds, and it seems that nothing can stop them. As the galaxies approach the dark flow, they are pulled apart by the immense gravitational forces. Stars are flung from their orbits, planets are torn from their systems, and entire galactic nuclei are disrupted. The very fabric of space-time is being stretched and distorted. But here's where things get really interesting. If the dark flow is a real phenomenon, then it means that our universe is not truly expanding. Instead, it's being dragged along by some unknown force. This discovery has far-reaching implications for our understanding of the universe. It challenges the very foundations of modern physics and raises fundamental questions about the nature of reality itself. For example, if there's something out there dragging our universe along, then what's beyond our universe? Is there a higher dimension or a parallel universe? And if so, what's happening over there? These questions have kept scientists awake at night and have sparked countless debates and discussions. Some scientists argue that the dark flow is simply a measurement error or a flaw in our understanding of the universe. Others argue that it's evidence of a larger, more complex structure to reality. The dark flow isn't just a fascinating scientific mystery. It also has practical implications for our understanding of the universe. For example, the discovery of the dark flow has led to the development of new telescopes and instruments that can measure the movement of galaxies with unprecedented accuracy. It's also led to the development of new models of the universe that take into account the effects of dark matter and dark energy. And let's not forget about the philosophical implications of the dark flow. The idea that our universe is being dragged along by some unknown force raises profound questions about our place in the universe. Are we just along for the ride? Or do we have some control over our fate? These questions have been pondered by philosophers for centuries, but the dark flow adds a new level of complexity to the discussion. Now, you might be wondering, how can I see the dark flow for myself? Unfortunately, it's not visible with the naked eye, or even most telescopes. The dark flow is only detectable through the movement of galaxies over millions of light years. But there are plans for new telescopes that could measure the dark flow more accurately. In fact, a team of scientists is working on the Square Kilometre Array, a radio telescope in South Africa that will be over 190 times more sensitive than any other radio telescope. With this telescope, scientists hope to measure the dark flow more accurately and better understand this mysterious phenomenon. So what should you take away from this video? First, the dark flow is a real and mysterious phenomenon that is challenging our understanding of the universe. Second, it has practical applications for things like developing new telescopes and models of the universe. Finally, it raises profound philosophical questions about our place in the universe. If you enjoyed this video, please like and share it with your friends. And if you're feeling extra generous, you can even subscribe to our channel. We've got lots more videos coming your way, so stay tuned for more updates. Thanks for watching, and we'll see you next time. Now, if you thought the dark flow was mind-bending, wait until you hear about this. Did you know that there's a place in space where the very laws of physics seem to break down? It's called the phantom zone, and it's a region of space that defies our understanding of gravity, light, and time. Join us as we explore the strange and mysterious world of the phantom zone and uncover the secrets of this bizarre anomaly. Click here to learn more. Or if you're looking for something else to watch, check out this video over here. Don't forget to hit the subscribe button so you never miss out on any of our incredible videos. Thanks for watching, and we'll see you next time.